Hey guys, Mr. Backerberg here. In this video, we're going to look at degrees and radians. Now, the whole idea of dividing a circle into 360 equal parts dates back to the ancient Sumerians and their base 60 number system. So as we think about a circle and we think about breaking a circle up into these degrees, we know that we can break one circle up into 360 degrees. But just like we can break whole numbers up into fractions and decimals, we can also break degrees up. We can break 1 degree into 60 minutes, but we can also break minutes up. We can break 1 minute up into 60 seconds. And we keep seeing these multiples of 60 show up. And again, that's because of the ancient Sumerian base 60 number system that all of this comes from. So in this first example, what we're going to look at doing is taking something that's written in what's called decimal degree form, and we're going to convert that into degrees, minutes, and seconds. So what we're going to look at first is the whole number of degrees that we're seeing. And here we've got 37 degrees, and we're going to leave that alone for right now. Now what we're going to do next is take that 0.425 degrees, and we're going to convert that into minutes. And we have to remember that there are 60 minutes in 1 degree. Now I'm going to take this 0.425 and put it over 1 so that we can multiply these fractions together. We should notice that we've got a degree on top and on bottom, so those labels are going to cancel each other out. When we take 0.425 times 60, we should get 25.5, and that's going to be in minutes now. So what I'm going to do is take the whole number portion of those minutes and attach it to this 37 degrees that we had before. So we're up to 37 degrees and 25 minutes. But now I need to take those 0.5 minutes and we're going to convert those into seconds. And we have to remember that there are 60 seconds in 1 minute. And again, I'm going to put this 0.5 over 1. Now my minutes labels are going to cancel out. When I take 0.5 times 60, I get 30 seconds. So I'm going to attach that onto the end here. So all in all, we have 37 degrees, 25 minutes, and 30 seconds. Now we can also work the other direction. Here we're given something that's written in degrees, minutes, and seconds, and we want to convert that into a decimal degree. Now we're going to work backwards here, and I'm going to start with that 36 seconds that we had. Now we know that in 1 minute there are 60 seconds. So if I put this 36 over 1, my seconds label is going to cancel out. Now when I multiply this fraction across the top, I'm going to get 36, and across the bottom I'm going to get 60. When I take 36 divided by 60, I get 0.6 minutes. Now what I'm going to do with that is attach it to the end of the 24 minutes that we had earlier, and then I need to convert these minutes into degrees. And we know that in 1 degree, there are 60 minutes. And again, if I put that 24.6 over 1, multiplying across the top, I'm going to get just 24.6, and across the bottom, I'm going to get 60. My minutes labels are going to cancel out, and this is going to be a degree answer. When I take 24.6 and divide it by 60, I get 0.41 degrees. Now I'm going to attach that onto the end of my 42 degrees, so I get 42.41 degrees. Now degrees aren't the only way that we can measure angles. A lot of times, especially when we're doing trigonometric things, we see radians being used to represent our angle measures. And a central angle of a circle has a measure of 1 radian if the angle intercepts an arc with the same measure as the radius of the circle. So as we take a look at a circle, a central angle is an angle that extends out from the center of our circle. And what's happening is this arc length that's being intercepted by this angle. As long as that arc length is the exact same size as the radius of our circle, then that means that the angle we're dealing with is 1 radian. Now what ends up happening with these radian measures, half of a circle, or 180 degrees, ends up being pi radians, meaning that a full circle, 360 degrees, is the same as 2 pi radians. Now we can use the fact that 180 degrees is the same as pi radians to help us convert back and forth between degrees and radians. If we want to go from radians to degrees, what we're going to do is multiply by 180 degrees over pi radians. But if we want to go the other way, from degrees to radians, we're going to flip that fraction over and multiply by pi radians over 180 degrees. So in this example, the first thing we want to look at is how many radians are in 90 degrees. So we're going to convert from degrees to radians. So what I'm going to do is take that 90 degrees and we're going to multiply by pi radians over 180 degrees. Now what's going to happen in here is these degree labels are going to cancel out. I'm going to put this 90 over 1 so that we can see the multiplication with these fractions. 90 times pi, I'm just going to leave written as 90 pi, but we've got that radian label, and this is going to be over 180. Now with this 90 over 180, I can reduce that down. Each one of those is divisible by 90. So on top, I just get pi. On bottom, I get 2, and this is a radian measure. So 90 degrees is the same as pi over 2 radians. Now we can also work the other direction. We want to see how many degrees are in pi over 3 radians. So I'm going to take that pi over 3, and that's a radian measure. To convert it to degrees, we're going to multiply by 180 degrees over pi radians. Now what's going to happen is our radian labels are going to cancel, and actually we've got a pi on top and a pi on bottom, so those are going to cancel each other out as well. Now as we look at what's left over across the top, we've got 180 degrees over 3 on the bottom. Now if we divide that out, we just end up getting 60 degrees. So pi over 3 radians is the same as 60 degrees. That's going to be it for this video. Thanks for watching.